Math was my favorite subject, I suppose, at school, but on the other hand, I was interested in this electronics. So I thought I'd do physics as being a compromise between the two. It wasn't. It was something completely different, I realized. There was a lot, the philosophy of physics is different. And I think physics is pretty special. And I'm glad that I did do it. But did not prepare me, it did not turn me into a mathematician, and it did not really allow me to do electronics. It was allowed me to do it, but think in all sorts of interesting ways, and realize that the relationship between the microscopic and the microscopic rules of behavior of atoms and the macroscopic behavior of the gas and so on is really interesting. And that difference is now crucial between the microscopic way in which two computers interact over the network and the way the whole web behaves, which we're now calling web science. The difference between the microscopic and the macroscopic is still a challenging step. My parents were both mathematicians. They had obviously had a lot of fun with math. So I grew up, I was the eldest, I am the eldest of four. We all grew up in an atmosphere where math was sort of interesting, was everywhere. So making clothing or making a pie or involves some calculations and things. And I suppose when I was little, I had two friends in elementary school, and we would discuss science. We weren't very athletic. We would walk around the playground and talk about chemistry and biology and physics, and we would wind electromagnets by taking wire from transformer wire and wrap it around a nail. I remember the electromagnets didn't work very well because the nail you should put in, the book said you should put the nail in the hearth in the embers of the fire and let it cool so that it got the right temper. But we didn't have a fire with embers. So that never happened, and the nail would become a permanent magnet. But that was the first sort of interest in I suppose, was to become later electronics. There I was in elementary school winding relays, making solenoids and relays out of wire, which is something you can do when you're in elementary school. Now, you can actually build something which does a certain amount of logic. You can build a gate out of relays made out of pieces of baked bean can torn up and connected to little, made into switches, and then those switches are operated by the electromagnets that you made out of nails and wire. So you could actually build a gate, and therefore you could build a register, and you could build the CPU of a computer, and you can build memory units. So in fact, if you had enough time and enough power and enough nails, you could actually build a whole computer out of nails. Later on, as I went through high school, then I came across a couple of teachers who were also great, who also, Daffy Pennell, who taught chemistry, Frank Grundy, who taught math, both excited, just bubbling over with enthusiasm, just so excited about the idea that, so you could talk to them, and they would just, after class, the class would all leave, and they'd continue to talk excitedly about something that maybe was going out from the curriculum to something that they were actually personally more interested in. And Frank was great when he would put a problem on the board. He would get, for the class, he would say, okay, work this out for n equals 2, and then for anybody who's interested, he sort of thought, is that true for all n? Or you know, is there a better way of doing this? Just these little teasers. Or he'd put up he'd end up with, having got through the algebra, with a sum. The difference between two numbers to the power of 3.5 or something, and he'd then write it down to three decimal places, and straight off, we thought that was magic, or he cheated, and then he'd explain how he'd use the binomial theorem, or whatever it is, you know, and how to do approximations. So he was full of, I guess it's the passion is the main thing, and just letting it radiate. So both of those were good mentors, role models. My mother was one of the earliest programmers. She and my father, he worked in London, but he took a train up to Manchester a whole lot, increasingly, as he got to know my mother. And then he moved down to London when they had me. And Ferrantis had an office in Putney, which later became International Computers and Tabulators, and then International Computers Limited. So they started off when the computer, when it was all of excitement about when the computer, a second register was added to the computer, a second accumulator. And so I think when they started, all of these mathematicians were full of the idea that you could do with a computer, what you could do with a computer was limited only by your imagination. Right? And you could prove that. You could prove that if somebody else built another computer which was fancier, you could program your computer to emulate that computer, and therefore your computer could do whatever their computer does. So it's just a question of the imagination you can put into the program. And that is quite a challenge. And I think later on with network information systems, people felt the same thing. This, wow, we can build huge systems. And now on the web, what you can do with building a website, what you can do building a new web application, it's limited only by your imagination. And that's the challenge that's out for people today. Computers changed. They had graphics. They had things like folders and point and click. And people started to use word processors. When they used word processors, they stored their data that they typed into the word processor on a disk somewhere on a machine, which generally wasn't accessible. So the frustration, there was then a new frustration that data about these systems was available, but you had to log on to a particular machine. You had to learn a particular program to access it. To find your way through the library was totally different from finding your way through the documentation system of an experiment. So the data was there somewhere going round and round on a disk, but it was really difficult to get at. So there was a mixture, a confluence of ideas, I suppose. The frustration that we didn't have access to the data that existed, even though it was there. The need for a collaborative environment. I want something like Inquire, but where everybody could play, so that people working together could design something in a common shared space. Creating the web was really mainly an act of desperation, because the situation without it was very, very, very difficult when I was working at CERN later. It was most of the technology which involved in the web, like the hypertext, like the internet, multi-font, text objects, had all been designed already. I just had to put them together. It was a step of generalizing all the sort of going to a higher level of abstraction, thinking about all the documentation systems out there as being possibly part of a larger imaginary documentation system. But then the engineering was fairly straightforward. It wasn't, and it was designed in order to make it possible to get at documentation, and in order to be able to get people, students working with me, contributing to the project, for example, to be able to come in and link in their ideas, so that we wouldn't lose it all if we didn't debrief them before they left, and so that people could. Really, it was designed to be a collaborative workspace for people to design a large system together. That was the exciting thing about it. The people who were crucial to the pickup of the web were, for example, people in companies who probably had day jobs but were doing this out of interest, engineers who were picking it up. If there had been patents around it, their lawyers would have told them not to even read the code, not to download it, not to install it, not to read anything about it, in case they were tainted by something which would allow the company later to be sued. So similarly, somebody else in their garage, their basement, just doing it for fun. They're doing it because they think it would be really exciting. Because they share the twinkle in their eye. Oh, they understand what it would be like if everybody had a web server, everybody had a web page, and everybody had a web browser. So they're just going to do, some of the people who do it because it would be cool if everybody did. Everybody realized that these new markets, these new spaces, these new ideas there will be new spaces of things in which other things will be built, but they all depend on the basic web infrastructure being royalty-free. It's always been like that. Every now and again, we've had a hiccup when somebody didn't understand it, when somebody thought that maybe they try to make a quick killing by somehow getting a stranglehold on it, somehow finding a way to be able to limit your access, everybody's access to the web, and then they'd be able to charge for it. Yeah, and and you could see that they had a different gleam in their eyes, but rapidly they found that really people treated them with the utmost contempt and programmed around them, went around them, and left them having learned a lesson and generally picking up the pieces and moving on and joining this world of openness, of open standards, of royalty-free standards. There are governments, and there have been governments always that have tried to limit access to information. I think it's a slow process, but I think it's inexorable. That connectivity it slowly extends itself. People want it desperately themselves individually. Governments realize bit by bit that actually having communication is very important for the economic well-being of a country. People realize that that trying to filter things is a losing battle. It sets you up for being, it makes the people who you filter out so much more energized and motivated to try to get around the censorship. So I don't think it's something which a country can change overnight. But I think that we're seeing it change inexorably, and so I'm optimistic about censorship slowly being lifted. There are lots of new things ready to be designed. Really, you have to think about the web technology at the moment, and the use we are using it as being a tip of a very large iceberg. Okay, when the first internet messages were sent, or the first email messages, some people may have thought, wow, we have changed the world now. You can send a message across the world just by typing it, and it arrives before you can read it out aloud. And so now, how will the world be different? As though there's been a sea change, and now we're going to settle down to a stable life in our new world. Wrong. The pace of change is increasing. It's not getting any slower. The web has happened, but it's one step. The web itself is it's part of the plan. We've got the data web, which we haven't got out there yet, and that's going to have very dramatic effects. Going to make us much more powerful in the things that we do. There are going to be a lot more things built on top of the web. There are going to be layers and layers on top of the web, and all the time, computers getting more powerful, people becoming connected together, the world being smaller. So there is very little time for sitting back and thinking, oh, look what we did. I'm just an ordinary person. Okay, I wrote this program fairly late in life compared to some people, compared to piano prodigies. And I'm just an ordinary person with ordinary faults and who's difficult to talk to on Monday mornings when they're grumpy and things. I have lots of problems remembering people's names and getting and turning up at appointments on time, and I'll get distracted easily, especially if there's some programming going on in the vicinity. So everybody is just a person. We're all just a person. I think we're all, if you like, we're all divine in some way. We've all got that. We've all got sparks. We're all very, very special, and that. So I don't want to explain what it's like to be special, because I'm not more special than anybody else.